In software engineering, we are taking chapter number 33, Estimation for Software Projects. Process-based estimation. Now, whenever we make a software, a project, we follow certain software development life cycle. So these consist of certain processes that in turn consist of activities, and these are divided into tasks. So this is how we complete a project, different decomposition part, and that is how we can estimate also. So what will be the effort, what will be the time to complete, what will be the cost. So the most common technique for estimating a project is to use the process as a base. Like we were using the function points, like we were using the line of codes, we can use the process. So in a normal SDLC, we start with the requirement analysis, requirement engineering. Before that, we do the planning, also risk analysis. And after this requirement engineering, then we do the design. Sometimes the requirement engineering and design are combined. Then the construction part and the deployment part. So we'll divide these into different parts so that we can divide the activities, action, task, and then we can find out the effort, which is we can estimate it. So process-based estimation begins with the delineation of software functions, because the function will come out from where? From the project scope. So first of all, you have to write the scope. Then from there, you need to find out the functions. From these functions, the process will be estimated or to be found out. There are certain framework activity that has to be performed for each function. Then we estimate the effort, and effort is always computed in person month. This is the unit also for each software process activity, for each software function. There can be some average labor rates, for example, the cost per unit effort. These are then applied to the effort estimated for each process activity. Okay, I'll give an example also. How do we do this? So these are the boxes. You will understand what I'm trying to suggest. So we are taking an example of process-based estimation. So what will be the effort required? What will be the cost? And how much time the project will take to complete? So in order to get all these, we will take the base as process. We will be taking normally the function points, the line of codes, the use cases. Now here we are taking the process as the base. So the problem here is the software product will be a software package to be developed for computer-aided design application, and this is made for mechanical components. So we have written a scope properly. We have found out written that into a bound state. Then we refined it, and finally we came up with the function. So basically this is the sizing part. From scope we came to function. So I'm just saying that this particular problem, we have already defined the function. These are the functions which are already been defined. I assume that all things have been done. So from scope, size, and this size, the base is we are using process. So ultimately the main key is the functions. So these are the functions, broad and major functions that we need to implement. For example, 2D geometric analysis, 3D geometric analysis, database management will be a part, user interface, user interaction will be a part. Then there will be various peripheral devices like the plotter, printer, laser printer, and joystick, mouse, many of these. So we divided try to find out the main function so that we can divide the work. Now each software engineering activity estimate of effort in person month. For each of these software engineering activity, whether you are taking the waterfall model or the spiral model or any of them, they are provided for this CAD software function. You see here the engineering and the construction, these release activities we have subdivided. That is, from requirement we start, then we do the design, Then we do the construction part, that is the coding part, and testing is also included here. And finally, we deploy the software or the application or the system. So the engineering and construction part, they basically we are talking about a requirement engineering and construction part. So requirement engineering and the construction, we would like to divide it because we can divide these activity into different tasks. For example, engineering into analysis design and construction into code and test. So gross estimate of effort are provided for the customer communication, because before that we need customer communication, we need the planning also because we are doing the project management, and finally the risk analysis. There will be some problem that may come, the contingency plan, what will be analyzed and what mitigation activity have to be done. And now you see the total row at the bottom, it is giving you the values of what we have to put here, and the percentage effort also, how much percent it is required. Now the horizontal and vertical, you see this horizontal one, totals, and there is a total on the right vertical, and that is row and column, last row and the last third in the bottom part. So this is the activity, top one is the activity, and we have divided this activity engineering into tasks, for example, analysis and design. And in construction, we do the coding and the testing. So the activity or the framework activity, we have divided two of them into two parts: engineering, analysis and design, construction as code and test. So now these functions, as I said, we have already found out. Now how much effort you are going to put for each function. For example, the first one, analysis part, requirement analysis part, 0.50. Then first one, the design part, 2.50. Similarly for construction release, these are the values being given, and depending upon the effort you are going to put. For example, in code, the maximum coding will be done in 3D GA and CGDF, that is three-dimensional geometric analysis, and the second one. So 3D GA, that is three-dimensional geometric analysis. Most of the time the testing will be done here only, 3D GA, so we put 3 here. Now this row, we are not giving anything to customer evaluation right now. So we are going to add this row, 0.5, 2.5, 0.40 and 5.0, we add them. Now these are the CC, that is the customer communication, planning and risk analysis. These we have given 11%, so 0.25, 0.25, 0.25. So row wise and column wise when we add, we'll get the same number, 46. Okay, so you see the total of every column, but the last column we add coming to 46. Similarly, the row with totals, we just add them and finally we get 46.00. So this is the effort only we are getting. Okay, so we are finally getting this number 46, which will be the base for other computation of the time and cost, etc. You see this engineering activity, requirement engineering activity, 45 and 8, 53% of the task is this only. So you got the idea? What are the rows and columns and how do we compute it? Okay. Now 53% of all effort is done or extended on front end engineering task. That is the requirement analysis and design part. 45% plus 8% is 53. So most of the work is done here. Now let us start the computation. Let us say that the labor rate is $8,000 per month. So the total cost which will be estimated will be what? See, 8,000 per month. How many what number we got there? 46. 46 is the person month because we are actually finding out the effort only. Now 46 just multiplied by 8,000. 46 is person month. So multiplied by 8,000. What do you get? And when you get this, I am multiplying it. It will be a number 368,000. This is the total estimated project cost. You also know the person month. You have computed the project cost. So effort and cost is known, right? And in this way also you can find out the time also, this span. So 46 into 8,000 is 368,000. Person month is 46. You can directly take from here. Okay. So this is the simplest example which I can give you for process-based estimation. Scope, sizing, and then this application. Estimation with use cases. Estimation is what? Finding out time, effort, and the cost. So here we have actors. This is a use case being made in UML, Unified Modeling Language. So an actor is someone who interacts with the system or the software. So a customer is an actor. Now he does certain activity like the open account function, deposit function, deposit fund, calculate bonus. So all these, the actor and these boxes or the round ovals, these are called transaction. It can extend, it can include. So these are called transactions. So use case, actor, and transaction. These are the three things which we try to find out from here. For understanding this, you need to know what is use case. So use case gives what? It gives us, like a software team, with insight into software scope and requirements. What is the software scope? What will be the requirements? So you can present it as a use case. Okay, as I said that UML in Unified Modeling Language, you can always present use cases. So now use cases, this can be used for, as you were using the function points and LOCs, a line of codes and process, you can use this use case to project the size of the software project. Time, effort, money. There are certain challenges here while using the use cases as the base, because you and me, both of us will make the UML in different style, different formats. There is no set that everyone will make same way. And this use case is actually a user's view. It is from external. You're not going to interior. And because you can make say 10 transactions. I can make only 2 transactions. So the level of abstraction or the detail which you and me are giving for a same use case will be different. And this use case does not address the complexity of the functions and the feature that are described. It is just saying these are the function and feature. Who is going to interact in what way? And after that you will see the state diagram and the sequence diagram, the swim lane diagram, all these things will come. But this use case will describe complex behavior, that is the interactions. If you see here, transactions are involving many functions and features. So we have various constraints, but still we can use these use case points to find out the UCPs. You know the function point analysis, function points you used to find out. Similarly way, we can find out the use case points or UCPs analogous to the function points. So what we have to do here is, I'll tell you all the procedure, but Cohen, he indicates computation of use points must take certain characteristics into account. First, the use case, number and complexity of use case. So first you have to go for the use case, how many actors are there, so the number and complexity of the actors on the system. Then third thing is, you have to also consider the non-functional requirement, which are portability, performance, maintainability like this, which are not written as use cases. There are environmental factors also for project development, programming language, software team motivation, that will also be included in the computation. So in order to begin, we have to know, if you start with use case, what is the complexity of use case? See here, a simple use case, it just indicates a simple user interface. So this is a simple use case. The complexity is simple. So simple use case may just be a user interface simple. It can be a single database. The number of transactions are less than 3 and 5 or less than 5 class implementation. So this is a simple complexity. If you say now my use case is average, so what do you say? A use case which is an average, it indicates a more complex user interface. It can have 2 to 3 database, unlike the previous one simple where only single database was there. And there can be the transaction between 4 to 7, the transaction I told you. When the use case are formed, we show the transaction or activity. For 5 to 10 classes will be there. When you say my use case is complex, that means you can have a complex user interface, and besides that you have multiple databases, and there can be 8 or more transactions and 11 or more classes. So depending upon that, you will divide or you will categorize your use case into simple, average and complex. Now every use case complexity have a weight. For example, simple will have a weight of 5, average will have a weight of 10, and complex will have a weight of 15. So this is the way we find out UUCW. UUCW is simply unadjusted use case weight, and this is the sum of all weighted counts. For example, your project has 2 simple use cases, 2 average use cases, and 1 complex use cases. I am taking an example. So you will multiply 5 into 2, you will get 10, 10 into 2, you will get 20, 15 into 1, 15, and you just add them. What do you get? 5 here, 4 here. So 45 will be the UUCW. Okay. Now I'll show you the expression, what all we have to find out, but first thing is UUCW. So this is the formula. UUCW is the first thing. We have to compute other factors also like UAW, TCF and other. Next part is we have to assess the actors. In a use case, how many actors are there? What type they are? What is the actor complexity? For example, if you categorize your actor as simple, these are simple. For example, a system which is defined working with API, another system, machine or device that communicate using application programming interface. If you say my actor is average, that is a system interacting through a protocol or a data store. Protocol can be TCP, IP or UDP like this. It is an average actor. Now if you say my actor has a complex complexity, that means a human or humans who communicate through this GUI or other human interface or user interacting through GUI. It can be a complex kind of actor complexity. Now we have already prescribed weight for each of them. Simple 1, average 2, complex 3. So for that we will find out finally the UAW, unadjusted actor weight. Now simple, for example, there are 2 actors, average 3 actors, complex 1 actor. So we multiply 1 and 2, you get 2, 3 into 2 6, and 3 into 1 3. So what do you get? 11. So this is the UAW or unadjusted actor weight. So as I told you, the expression, 2 values we have found out. Apart from that, we also need TCF and ECF. TCF is simply technical complexity factor. These unadjusted 2 values which we just found out are modified considering this TCF, technical complexity factor, and the environmental complexity factor, which is the ECF. There are 13 factors that contribute to TCF, 8 factors contribute to ECF. I'll just show you what they are. But UUCW, you know how to find out. UAW, I just found out here. TCF and ECF are the 13 and 8 factors. We will give you the values and compute it. You'll just know how to compute this TCF and ECF. Then finally UCP will be found. So we have an example. In order to estimate using use case points. So the project or the problem, the software we have to make is a software package to be developed for computer-aided design application for mechanical components. So this software package, a scope has been written. The scope has been properly defined, refined, and finally from the scope we found out the functions. So this is the basic formula for the use case point computation. So all these 4 we are going to compute one by one. Before that, we need to know how many functions are there, major functions in this project. So as I said, we'll write the scope and then we will try to bound these sentences or narrations. Then we'll try to find out the functions from there and major function, and then we'll start our use case point computation. So let me tell you, or let us assume that these all CAD software functions we have found out, because in CAD we have to do two-dimensional geometric analysis, three-dimensional geometric analysis like this. For example, we have to do the peripheral control functions. So all these have been defined. Now this particular example, certain values are already given. I just say that this can be categorized. The example CAD software has 3 subsystem groups. First is user interface subsystem. It has UICF. Engineering subsystem group. It has this 2D GA, 3D GA, DAM, which is the design analysis module. Don't go into the detail, okay? I'm just giving you numbers right now. I'm just explaining how to get these numbers. And in infrastructure subsystem group, you have CGDF and PCF, that is computer graphic display facility, and you have peripheral control function. Now the numbers of all these I'm giving you, okay? So the computation starts from here. Just assume that we know the software, we know the values now, so we have defined the use case now. So 16 complex use cases describe the user interface subsystem, the first one. These are 16 complex, okay? So the first one, I am talking about this box. So complex. The engineering subsystem group, this is described by 14 average use cases and 8 simple use cases. I am all talking only about use cases here. So we have 14 average, 16 complex, and 8 simple use cases. The last one, infrastructure subsystem group, it has 10 simple use cases. So either you combine this, make it 18, or you can do it separately also. Good idea is to combine them, 10 and 8, 18. We have done the use case part. Now let us come to the actor part. Now we assume that we have 8 simple actors. So now this box is for actors. 8 simple actors. We have 12 average actors and 4 complex actors. Okay. Now how do we compute what will be the final value of UUCW and UAW? Let us see. We multiply with the weighting factor or weight factor, and then we add 8 into 1, 12 into 2, and 4 into 3. Then we add. Okay. So first one value will be UUCW, second value will be UAW. You'll just see how we do it. Let me show it here. You just see the final equation. Now, as I said, how much values were there? We just discussed. So the complex were 16 use cases. 16 use cases were there. So 15 is already the weight. So multiply. Now, we have to write at NCUC 16 in place of NAUC, that is the average complexity use cases is 14. And as I said, we have already 18, 8 plus 10, 18. You can use like that, or you can make it 18, or you can use 8 use cases and then 10 use cases. Ultimately, you have to multiply it with 5. So 5 into 18 will be this value. And from here and here it will come. 10 into 14, you write here. 15 into 16, you write here. So we have already done the computation. 16 into 15 plus 14 into 10 plus 18 into 5. Or you can do 8 into 5 plus 10 into 5. Finally, a 470 will come. UUCW is 470. 470. I'm not doing the whole calculation. UAW, how to find out the UAW? See, UUCW already found out and adjusted use case weight. Now we are going to the actors. Okay, how many actors were there? 8 simple actors, 12 average actors, and 2 complex actors. Now multiply them. 8 into 1 is 8, 12 into 2 is 24, 3 into 3 is 9. Just add them, you'll get 44. We already computed it, so I'm just writing it. 44. Now coming to TCF and ECF. I'm just writing the numbers also. Now TCF we have to find out. TCF, these are T1 to T13. These are what? These are technical factor. Now, T1 to T13. These are the names. Now the weight is already fixed. This is already known. You are not going to change it. But you have to, depending upon your project, you have to give a value from 0 to 5 in this column. For example, randomly I'm giving some value. You have to give a value from 0 to 5. It has only to be between 0 to 5. So 5, 2, 3, 2, 1. Like depending upon your project, you have to spend time on this. Now multiply this. 2 into 1, 2, 1 into 2, 2. Like this, every 2 values you have to multiply. And finally, what you get this in this column, you have to add. Add all of these in this column. So you will get T factor. total technical factor. This is not TCF. You get a T factor. For TCF, there is an expression. What is the expression? 0.6 plus 0.01 into T factor. So you have given the value here from 0 to 5. You got the last column. You added the last column. That is going to be T factor. And put it here in this formula. When you put this, you will put value in this formula. You will get a TCF. I'll just tell you what the TCF value will be. Before that, let me go to ECF. ECF is for environmental factor. So these are F1 to F8. This description is like you want to value something for motivation. So you have to give value from 0 to 5. These weights which are given from 1.5 to minus 1.0, these are fixed. These are fixed. You don't change it. Now you have to give the rated value from 0 to 5. For example, motivation is there. You get a 3 value. You multiply 3 into 1. You will get 3 in the last column. Same way. So 1.5 into 1. What do you get? 1.5 here in the last column. 0.5 into 0. You get a 0. So you have to do for each of them. I hope you will be able to do and just write every value and add them. That is going to be a E factor. I'm not saying it is ECF. It is E factor. Again, we have an expression for ECF. ECF is 1.4 plus minus 0.03 into E factor. Now put this E factor here. So I'm just saying that we have already done the computation. You have given the value, rated value. Let us say that the TCF comes to be 1.04. ECF comes to be 0.96. Okay. You got the T factor, put it here, you will get the TCF. You got the E factor, put it here, you will get the ECF. You may give any number from 0 to 5 in all the columns I said. So either the values may change. I have given these values, so I get 1.04 and 0.96. So now what all values you have? See, UUCW is 470, UAW is 44, TCF is 1.04 and ECF is 0.96. Okay. Now, after evaluation of technology and environment, we have just seen, we have got the TCF and ECF. And now we are ready for the final expression. 470, 44, 1.04 and 0.96. 513 will come. Now, 513 is our final value, the use case points. Now, what is the significance of this 513? What to do with this 513? This is whole of the flow chart I have shown. So, for example, using the past project data, the development group has produced 85 line of code per UCP. That is, for one UCP, each UCP, there will be 85 line of codes will be written. So, we have 513 here. And the overall size of the project we just saw is what will be there. 85 is LOC per UCP, multiplied with 513 UCP. Multiply 513. You got the use case points. Multiplied with the 85 LOC per UCP, you will get 43,605. Let us take it as 43,600. Now, similar computation can be made for applied effort or project duration. Say we have 620 LOC per month as the average productivity for system of this type, and there is a labor rate of 8,000 per month. This is also given to us with our past experience and past projects cost and the present cost. So what will be the cost per line of code? What will come? See, we already know, we already done that. So we have this 8,000 is the cost. Take this, divide it with the 620 LOC per month. So you get 13. So this will be the cost of per line of code. Now, based on the user estimate, use case estimate and the historical productivity data, the total projected cost will be what? 13 is the cost per line of code, and we have 43,600 lines. So multiply this 13 into 43600. What do you get? 556,800. Now we have the historical data also, so you can just combine them and average them. So you will get 552,000. Even if you want to keep 566,800, it's good. It's similar to that value only. The difference is not that much. Now effort also you have to find out. The estimated effort will be what? See, there are values we have already found out. So we find out the person month. So you have the line of code 43600. You have 620 LOC per month. Divide them. What do you get? 70 person month. This is the use of UCP. How do you find out the estimation, the cost, effort and duration of a project? reconciling estimates. Sometimes we use the function point methods, sometimes we use the use case or the process or LOC method. But the estimates, sometimes when we combine them, the estimates are sometimes poor. So these widely divergent estimates can have one of the two causes. The scope of the project is not adequately understood or has been misinterpreted by the planner. This can happen. Or the productivity data which is used for problem-based estimation technique is inappropriate for the application, obsolete, or has been misapplied. So sometimes you face this. The structure of estimation models. Now this is the base for our COCOMO model. We'll talk about that in the later discussion. Till then, thank you so much. Take care of yourself.